this is 8-1 answers. And this was the exploring exponential models, being able to recognize growth and decay. Do you remember the model is y equals ab to the x? Oops, here we go. Y equals ab to the x. Which one of those letters did you look at to really recognize if it was growth or decay? B. That's right. So number one was y equals 72 times 1.6 to the x. We would call that G for growth. And 2 was y equals 24 times 0.8 to the x. What do we call that? D for decay, because of the 0.8 will make it slowly shrink away, decay. Never touching 0, but getting there. 3 is y equals 3 to the 6/5 to the x. Will be growth, right? 1 1/5. And 4, y equals 7 to the 2/3 to the x. Decay again. All right. So a really easy way of recognizing when something's growing or decaying. Then 5, 6, and 7 is a sketch graph of each function. Identify the horizontal asymptote. So I just had you guys, I know we're not going to spend a lot of time on these, just make a quick graph, give a general idea. 5 was y equals 0.3 to the x. The easiest thing to know is if I had 0 in for x, what's the y-intercept? Where's it going to be touching the y-axis? 1, so we're going to call that 0, 1. And will this thing grow or decay? So I would go to put a point on the y-axis, and so this thing's going to come down, it's going to cross at 1, and it's going to approach, but pretend like I did not touch that. Just pretend like that thing is going out there and approaching to the point you can't tell. It's not touching. It's not ever touching that asymptote. We'd say the asymptote ASY, I'll read it. It's just y equals 0, or the x-axis right there. It's never touching it. 6, same thing. Here we got just y equals 3 to the x. What would be its, if we have 0 in for the x, that's the y-intercept, where is it going to touch the y-axis? 1 again, because there's not an a. You might notice neither one of both these have an understood 1 as an a. There's not another number here. There's not another number here to multiply. And it is growth, right, guys? So, and honestly, I made that curve a little too flat. That'd probably shoot up there even flat and higher. A lot of times on your ACTs and stuff like that, if you're able to know the difference between growth and decay, and later on we'll talk about how H and K can shift that graph, shift it left and right, up and down. And this graph can be reflected if we were to put a negative sign out here. So just understanding how to pick up on those. Okay. 7 is y equals 2 to the 1 times 1/5 to the x. Whereas this one's y-intercept at 2. You put a 0 in there, you get 1 times 2, and is it growth or decay? Oh my goodness, I made a horrible decay curve. But it looked like that. It'd come down, it'd cross it 2, and again, the asymptote is y equals 0. Same thing on 6. I didn't say that. The same thing on 6, the asymptote is y equals 6. Let me go back here now. I don't remember where I put it. Okay. 14, you have to find the model, and y equals ab to the x model for this. And you have a point that goes through 0, 2, and a point that goes through 1, 1.3. 0, 2 is kind of nice. When x is 0, you get an output of 2. So that tells us, if you were to look at that, 2 is what you get when you have b to the 0. B to the 0 is 1, so 2 must be the a, right? There must be a 2 sitting right there as a y-intercept. So then we plug that in over here. We use the other point. 1.3 is what you get. That's the y. You have an a of 2 and a b of 1. This one's kind of simple. So that simplifies. B to the first power is just b, so it's 1.3 equals 2b. And when you divide the 2, what do we find out that 1.3 divided by 2 is? I think we did this the other day. It's one, if you divide 2 off, what's 1.3 divided by 2? Y'all should have it on your paper. What was it? 0.65, thank you. So our model, our y equals abx model, with given those 2 points, we found a here and we found b here. So it'd be y equals 2 times 0.65 to the x. That exponential model would fit those 2 data points. 15 and 16 was a little more interesting. 15 and 16 didn't have as easy of points, but we did 15 together, and I had you try 16, right? So we'll see if you ended up with it. 15, though, we did together, it was these 2 points. We had -1 and 12.5 and 4.096. Same thing, we're going to plug those in, so we just using the first point, 12.5 would equal a, b to the -1. Solving for a, rewrite that, that'd be 12.5 equals, because that's a negative exponent, it'd be a over b. Right. So what do we do? How would I get just a? Multiply by b. So 12.5b is a. That's a 12.5 right there. Then we take that and use the other point. Another point right here, we say the output is 4.096. When a is replaced, instead of using a, we use that as a substitute. 12.5b times another b raised to the 4th this time. That's the input. When we multiply here, we get 4.096 equals 12.5b to the what? 5th. Be the first times be the 4th. That's a 5, sorry. Divide that off. Help me out here. Use your calculators. I think you have already. What's 4.096 divided by 12.5? Something like that. I believe you. And then we said, well, to get that as just b, we would take the 5th root or raise it to the 1/5, raise both sides to the 1/5, and what do you get? 0.8. Very good. So we can write our model. It would be y equals 12.5 times 0.8, that's the b, to the x. It's algebra there. That's a heavy algebra type problem, algebraic thing where you're rearranging. Okay, and then you guys tried 16 on your own. So look closely. I'm going to pause for just a second here, because I know some of you are still looking at your 16. Take a good close look at your 16. Take your calculator. Check your math. 16 had 1.84, not 0.084, right? 2, 1.08. At these 2 points, take a close look at your math, use your calculator. Let's see if the numbers line up with mine. So the first one, 0.84, is the output when the input of right here is 1. So if I solve that, b to the first power is still just b. If we solve that, we would say 0.84 divided by b is a. Everybody agree with that step? And we got to come over here and somehow make that happen on the other one. So 1.008 would be, instead of an a, I'm going to use 0.84 over b. Why did I put an equal sign there? I don't know. It's supposed to be a times, this is another b, to what power? The second, right? So 0.84 over b took the place of the a, and there's the b, and the input this time is the 2, so we used it as the exponent. B in the denominator, b squared up here, if I simplify that, how much would that leave me? B to what? Yeah, so this is just 0.84, because if you look at this a different way, that would be b squared is b times b in the numerator, and b in the denominator would be like that. So you could eliminate, cancel out a b in the numerator and the b in the denominator and leave just b there. That's how you subtract, right? Is that a lot of b? What up, b? Be cool. All right, so then you divide. What number do you end up with there? 0.7? I don't know. You tell me. Divide. Take your calculator, check your math. I don't know. 1.2? 0.7? What is B? Everybody, take your calculators. Let's all check every. What is it? 1.2. Logan, what do you got? Take your calculator and divide. This is easy math. Don't trust your neighbor. Like, check yourself. I'm getting several 1.2s. Okay, so we got a B. So let's write our model. Y equals, we don't have our A yet. What do I do to get an A? What is that? That's the 0.7? Okay. That's 0.7. 1.2 is the B. What do I put there? It's an X. There's the model for that one. Okay. Let's pause the video. Stop the video.